just so that when we take the register of attendance at the end, we can make sure that your attendance is checked off. Please make sure that you are ready to jump in if I ask any questions, and full name and your school if possible, although that should come up, I think. So let's get going. Remember, can we, as much as possible, have cameras on? I do understand that some school computers may not have a camera. That's absolutely fine. Please be on mute and unmute if you, thank you to whoever that was. Unmute if I have a question, or if you've got any questions, you can put your hand up and you can jump in as we go along. So this is your Year 1 ECT subject session 3. It's all about science. And we are looking at what does vocabulary instruction look like in the science classroom, and what does it mean to talk like a scientist? So when should children be talking? What should they be talking about? What are the non-negotiables of talking like a scientist? How do we teach talk in the classroom? And how do we create opportunities for talk? So there's been 2 big pieces of research out in the last year. So we had the review of scientific literacy and oracy in the primary school education. And we've also had building a world-class curriculum for all. These are things that I'm going to be tapping into. Again, all the links are there. They're really informative documents, but it has really pushed forward sort of the oracy element in particular of scientific literacy. So really important stepping stones and stepping forward. So first of all, what do we mean by disciplinary literacy? Because I don't know about you, but you get, particularly in the first couple of years, you get all these new terms banded around, and it can get really confusing about what means what. So disciplinary literacy refers to the specialist ways reading, writing, and oral language are used in academic disciplines such as science, history, or literature. Each field of study has its own special way of using text to create, communicate, and evaluate knowledge. Students need to gain an understanding and appreciation of how historians, scientists, literary critics, mathematicians, and other experts use literacy, along with developing their own nascent abilities to engage successfully in such practices themselves. Now, that's really important, because as we know as teachers, if you are writing in science, you're generally writing you're writing non-fiction. It's professional voice. You are not going to write a story. And it's really interesting how so many children, particularly if you ask them to write something, they start embellishing it. And actually, we need to learn that as scientists, we're very factual, we're very matter of fact, almost a little bit less is more. So it's really important for children and you to be able to teach children that there are different ways of writing for different purposes. So why does it matter? So the EEF tells us that there is an attainment gap in science at every stage. It is apparent at the end of Key Stage 1 and gets wider throughout primary and secondary, with the gaps growing particularly strongly in ages 5 to 7 and 11 to 16. The stronger factor affecting pupils' science scores is their literacy levels. So actually, what we're finding is that literacy is a barrier to them showing their knowledge. Now, I'm actually dyslexic myself, and it's really important that for me as a teacher that I want to know what the science is that the children know, not what the barrier is to them showing me in their books. So can we use oracy and their discussions to actually evaluate how much science do they really know? Are they good at science? Rather than how much have they written on the page? So disciplinary literacy helps students adopt scientific language, develop scientific reasoning, explanation skills, and engagement. These skills help counter misinformation and foster critical thinking in a complex world. And we know the world around us is very complex, and the information that they're gathering, some of it can be 100% completely inaccurate. And we have people trying to, particularly on social media, saying, oh, well, this is brilliant because it does this, this, and this. But actually, what are their qualifications behind them? There might be none. And so they're sometimes gathering misinformation. So actually, science really helps them with guiding them, with looking at the evidence around them and saying, actually, is this likely or is it unlikely? How true is this potentially? Now, science language is like learning a whole new language in itself. And it's important we develop pupils' fluency in this particular in our particular language. It's almost like saying that we've got, you know, we're talking Spanish, for instance. So to become competent in the language of science, pupils need to be able to comprehend, analyse and interpret texts. They also need to use the language of science to explain their ideas and construct evidence-based explanations. So thinking about those conclusions that we get the children to write, which helps them to explain what they've understood. This may seem like something that needs extra time and work, but actually it's just the core of science. It's what we do when we are teaching, every single time we teach science. So closing the vocabulary gap. There are, sorry, I've gone the wrong way, gone too fast. So approaches to developing vocabulary can be split into two groups. We can do explicit teaching of new vocabulary, where, you know, you might have a couple of words on the board and we make sure that we're teaching them those key words. You might have a vocabulary, might have a vocabulary bookmark. We can also think about just exposure to rich language environment with the opportunity to hear and confidently experiment with new words, including modelling and scaffolding. So just the fact that we ourselves are talking in a scientific manner in our classrooms is modelling and exposing children to that rich language. The fact that they're in your lessons and they are learning things like a beaker. So instead of just a measuring jug, we're starting to give them that scientific vocabulary, and that is really important. So what does explicit vocabulary instruction look like in the science classroom? We need to be aware of the vocabulary demands of the topic and make conscious choices about the words that we are going to teach. I would recommend that you don't do more than 4 per lesson. Otherwise, you're increasing the cognitive load. It doesn't mean you're not going to use any other scientific vocabulary in that lesson. It's just that we're focusing in on those 4 particular words that are important to that particular lesson. So focus on words that people, as I said, people really need to understand. Make sure they understand them well. So you could be thinking about the fact that, you know, we are so lucky that science is a vocabulary rich environment anyway. But it's essential that they understand the differences in words. Vocabulary should be explicitly assessed in science, perhaps more so than in any other non-language subject. In fact, the EES report in relation to science had a huge area based around vocabulary and its importance for children to be able to learn science. So when we think about that vocabulary, we talk about in school, tier 1, tier 2, and tier 3 vocabulary. So what does that mean to science? Well, tier 1 are words that are sort of everyday. So pool, squash, water, they are in our everyday language. So that would be tier 1. Tier 2, it's words that can come in multiple curriculum areas. So conclude, it doesn't have to be just science. Examine doesn't have to be just science. It could be you're examining something, a piece of evidence in history, for instance, or geography. You might have gone out on a field studies trip and you might then come back with your data and you might bring in that conclusion. Then we've got the tier 3 vocabulary. That is subject specific vocabulary. For instance, photosynthesis would not necessarily be used in any other subject other than science. Habitat and oxygen are other examples. So then we need to think about our progression of vocabulary through the years. So here's an example. So in early years, we might use pull and squeeze. By key stage 1, we're thinking about stretch and squash, and bend, and other words are bend and twist. We might have elastic, bend and stretch, then extension, then tension, and then right up to key stage 5 is tensile. The reason I have given that progression of vocabulary all the way through is as a reminder that all learning starts in the early years, number 1, but actually all children in the UK have to do science GCSE. And although we are primary teachers, what we teach underpins everything they go on to do. And the more successful they are in primary science, the more successful they are in secondary and at GCSE. So that's really important to make sure that we understand that. It's a journey and we are part of a big picture of a journey. So the EEF says language learning in the classroom, suggests several strategies for teaching vocabulary and modelling language use in the classroom. The following techniques can be used as part of teacher modelling. We can introduce words through explanations in everyday language rather than dictionary definitions. We can provide several contexts in which the word can be used purposefully or with different meanings. We can develop activities that require pupils to process the meanings of words thoughtfully, e.g. getting pupils to think about meanings by identifying and explaining how words are used. We can provide examples, situations and questions that are interesting and create discussion. And we can create retrieval activities to assess pupils' understanding over time. And I think that's really important. We need to ensure that that they are utilising this language regularly. A language is complex. Let's not beat around the bush. And I think English in particular can be very complex. Strategies to teach unfamiliar scientific vocabulary include modelling. We need to say the word to students using the correct pronunciation. We need to write it, show them, and they need to write it as well. Break the word down into its parts, repeat it, and discuss the etymology of the word, which means the origin or the root of the word. And we need to provide example sentences that use that word. We need to teach our science-specific vocabulary because they might not have come across some of these words in everyday life, or they might have come across the word, but used in a completely different context. So some vocabulary will be outside of normal day conversation. It's not every day that you would use the word photosynthesis in your conversation. And some vocabulary, as I was saying, might have multiple meanings, which makes things even more challenging for children, particularly if you think that they might be EAL, they might be learning the language, or they might have additional learning needs. It can get really complicated. So let's look at same word, different meanings. Some familiar words have a different meaning in science from everyday life. And several studies have shown that these words often cause more problems for pupils than words we might normally consider to be technical. So field. Most children will think of a field as a playing field or a sports field, but actually in science, we actually have a field around a magnet. Material. And this we learn in year 1 and 2. Remember, it's key stage 1 here. So a material is actually in science the objects, the material that all objects are made of. But most children in everyday life will use the word material relating to their clothing. A circuit. We might think of a circuit on a running track, or a circuit of a Formula One racetrack, for instance. But what about our electrical circuits? Because they don't see them, they might not have heard of an electrical circuit until we bring that into their vocabulary. Conductor. They might think of a conductor as a bus conductor or a train conductor. What about a musical conductor? But then also, we have a conductor that allows something to pass through. And not only do we have just one conductor in science, we have an electrical conductor, we have a thermal conductor. So again, making it even more complicated. So one way you can help with this is we can think about how to explore the structure of the words. So we can explore common word roots, showing pupils how words are linked and how to use them in a range of different contexts. So an example would be thermometer, therm and thermal. So Greek word therm meaning heat. So therefore thermal is to do with heat and thermometer measures heat. We also have photo, so photograph, which children may be familiar with, but they might not know about photosynthesis. But the root word there is photo, which means light. So photograph needs light to take the photo. Photosynthesis needs light for the leaves to make their own food. Sorry, I'm just letting someone in. So pinning down those, it's a bit like when we talk in maths about mono and bi. So mono meaning 1 and bi meaning 2. So utilising that and actually making links between subjects as well. They might have come across the root word in a different subject, and we can use that to our advantage in science. So where do I find the right vocabulary? So one of the places I always recommend is an online platform which is free called Plan Assessment. The link is there on the address is there on the slide. They have already made a progression vocabulary for you, and really useful to tap into just to see, am I using the right level of words? There is no reason you can't mention some more complex words, but don't introduce them too hard and fast too early, because there's a lot of learning to be done, and we don't want to get bogged down in too much complex language. I often use sort of dual words. So for instance, I might say, what is the thing that we are changing? What is the variable we are changing? So variable being the scientific term, thing would be a tier 1 level vocabulary, but it gets them to understand what variable means when we're doing the experiments. How can we expand children's vocabulary in science? We can think about reading. So when children are interested in a topic or subject, they naturally gravitate towards texts in the library that may be available to them. Research tells us that extended reading rarely happens in science lessons, but reading authentic text is a good way of exposing pupils to scientific writing. Now, with that in mind, we don't often do sort of reading in science other than maybe a text that you're giving them to then analyse. Now, with this, some of the books that we've got here are Extraordinary Life of series, Little People, Big Dreams series, The Horrible Sciences, and on the right there's Whiz Pop Bang magazine, which I've tested out with children. They find it really interesting. It's really quite fun, and maybe a good alternative text type to get children into reading about science. We actually implemented some of these books in our library, and from the data from our reading scheme, it actually showed that these were some of the most popular books with the children. So having a good variety of books available is really important. So I want you to have just a quick second to think for yourselves. Have you seen any of these books in your school? Are they available for the children to pick up and take and read, either in school, or are they part of your library that they can be taken home and brought back in? Or do you think, oh, actually, I might go and have a word with my science lead about that and see whether we can add that to our collection? So language literacy and oracy. Scientific literacy itself depends on oracy. By talking through scientific ideas, pupils practice reasoning, explanation, and evidence-based thinking, the same skills scientists use to make sense of the world. When pupils share ideas, challenge misconceptions, and explain their reasoning, they're not only learning science content, but also learning how science works. So what is oracy? It's articulating ideas, developing understanding, and engaging with others through speaking, listening, and communication. An approach that makes science something pupils can explore, question, and make sense of together. I think that's really important. And the reason I highlighted the word listening is quite often we automatically think of oracy as just speaking, but actually it's about communication. It's about taking the turn. It's about active listening. Because if we're active listening, we can actively communicate and we can actively then verbalize what we want to say. So the importance of oracy in developing scientific understanding has taken centre stage in two major reports published last year. I showed them at the very beginning of this presentation. The Royal Society's review on scientific literacy and oracy in primary education and the Curriculum and Assessment Review. Both highlight the need for pupils to learn through talk, not just about it. So why oracy needs to sit at the centre of STEM learning? Oracy is not just, and this is from the CEO of Voice 21, so oracy is not just about speaking well. It's about pupils being able to articulate ideas, develop understanding, and engage with others. In STEM, abstract concepts and problem solving, talk is often the missing step that helps everything make sense. Sometimes in lessons, because our lessons are tight, and I know very much so that science is a really busy lesson, particularly if you have a practical or an experiment happening in that lesson. And therefore, sometimes we rush the talk bit, but actually that's often the most powerful bit to show that the children are really understanding what's going on and what's going on in the experiment or the practical and what their understanding is. And I would argue that actually sometimes you need to think about which bit do I want them to record in their book? Do I really need the whole experiment written down? Or can we just focus on one aspect? And then maybe the next one we focus on another aspect. So could we focus on a conclusion one day? Could we focus on the variables a different day? Generally in primary, I don't get them to write a full method. I would rather have that discussion and give that time over. So the Curriculum Assessment Review places a renewed emphasis on oracy as a core skill. This will mean a shift towards deliberately planning for talk, giving pupils time to discuss their thinking and creating routines where questioning, reasoning, explanation become part of normal practice. And that's why I was saying about thinking about which bits do I need to record in the book, written record, because that is still a really important skill, learning to write like a scientist, but also which bits can I maybe reduce that time so that we have more time to give over to oracy. In science, oral critique is a core to the subject. The approaches below may support the inclusion of regular and meaningful opportunities. So, for instance, we could introduce planned and strictly controlled opportunities for structured talk in science lessons. Structured talk is not discussion, it's separate. It must be deliberate and strictly controlled in terms of time and subject. So it's almost like that that turn to your partner. So you presented a question, turn to your partner, partner A, say X, partner B, respond, and then feedback. Opportunities for planned discussion should reinforce the importance of accurate subject knowledge and scientific reasoning. So how do we expose children to a rich language environment with opportunities to hear and confidently experiment with new words? Well, we're really lucky in science because all those new words are fully embedded in our curriculum anyway, and in everything we do. And it's in the environment around you. You've probably got keywords on your displays as well, or you might have a working wall. So one of the things that we do is talk like a scientist. So I think we think carefully about what does that actually look like. So it could be that if you've asked a question, the children are responding to that question. What does that look like? Is it one child? Is it partner talk? Who should be talking? When should they be talking? And what should they be talking about? What are the non-negotiables? My non-negotiable is it has to be a full sentence. We're not giving one-word answers unless it's a quick fire round. My turn, your turn, my turn, your turn, like a quick, rapid recall. Otherwise, I expect them to phrase their answer into a full sentence. It's thinking about how we teach and model talking. So we might give them the sentence start verbally, and then they use that sentence start to answer back, and making sure we create those opportunities. So Talk for Primary Science was from the Royal Society of Chemistry. Now, talk helps children use scientific language effectively and develop their understanding of scientific ideas. Right across the curriculum, talk engages children, motivates them to use their speaking and listening skills, and helps them learn how to respect and respond to each other. It reinforces the idea that mistakes can be opportunities for learning. And I think that's really important, that actually, if we're not making mistakes, we're not learning because we already know it. And that's a really important mind shift to the children, because children don't like making mistakes, particularly if other people are watching. So leading children to find their own answers to problems, in science especially. Exploratory talk helps children develop their inquiry and reasoning. Now, I have actually got a video here, but I'm very aware some of you might be sitting in classrooms with no air conditioning, like myself. So what I'm going to do is, instead of playing the video, I'm going to let the centre send you the video links and you can watch them afterwards, okay? And that will claw back a few minutes for us. So when should children talk? We can have structured talk versus group discussion. They are two very different things. And that's really important to make sure that we know what those two different things are. So Neil Mercier and Lynn Dawes found that explicitly teaching children to work together more effectively in groups improved their language and reasoning skills and led to higher levels of attainment in science. Now, only 2 weeks ago, in one of my classes, we actually did a STEM sprint, and the children were working in groups. On day one, they really struggled to work together as a team for the common goal. It was very much, no, I'm doing it this way. No, I want to do this. No, I want to do this. By the end of the 4 days, I saw a real improvement. And I think science is one of those areas where actually we really can develop group work, particularly when we're doing practicals and experiments. So I really think about making sure children are working groups, but then also thinking about, do I need to give them a role so that we're not just over talking each other, playing to the children's strengths. I would always suggest I would generally not go to groups bigger than about 4, I find after that you've always got a couple of children that are sat back, not really engaging and just letting the others take over. So really think about your groupings. Who group? Are they going to mix mixed ability, or are you wanting to stretch your most able with a slightly different experiment? So thinking about how that's going to look in your classroom is really important, and planning for it is important. Structured talk, as I said before, is more focused talk. It's things like turn to your partner or partner 1, partner 2. Whereas group is that more open, longer task discussions. Another thing that children find really difficult is that compromise. And as well, and it's that reminder that oracy includes communication and listening. And listening includes valuing each other's thoughts and opinions, even if they don't agree. It's about making sure that children go, okay, I'm listening to you. I hear what you're saying, but can we change that? Now, obviously, that's going to look different at different age groups. But it's still something we need to make sure we're building in. So Neil Mercier said, a classroom filled with exploratory talk is filled with problem solving, collaboration, and thinking. And if they're actively listening, they're actively communicating, actually you're going to get better science from the children. Because if they can explain what they have seen, it really shows that they have really understood the concepts. And I think that's really important as well. So what is quality science talk like in your classroom? So I want you to have a quick think, and you can pop something in the chat. What is going well? Something you hadn't thought of yet, or even better if. So what does it look like in your classroom? Is there anything that I've said already today that you've gone, actually, I need to do a bit more of that? Or, oh, could I focus more in on understanding the meanings of the words? Am I giving enough time to exploring the fact that that one word means something else in a different scenario? Am I doing talk like a scientist already? How does that look? It'd be really good if I could have some feedback in the chat. So what may be going well, or something that you may want to work on. I'm going to give you 1 minute. Good. A lot of pair discussion is great. And then think about mixing that up with some group discussion as well. Pair discussion is great because it actually gives children confidence to speak out because they've had their ideas verified. Grouping and letting them talk about it, yep. Using visuals and sentence stems with a lot of use of key vocabulary. Yeah, there's a lot of, and I think that's one of the things. I don't know whether a lot of your classes use something like pictures like widgets. If you do, really important that you make sure you get the right one that suits the science term, because often, sometimes they're coming up and it's not scientifically helpful. So making sure vocabulary is discussed more. Even better if I'd like to spend more time giving examples to children using key vocabulary words. Excellent. I use a lot of group discussion in science, more so than in other subjects. I think science really lends itself to that, actually. I think we're quite lucky with science. Group of 4, with first lesson being a total flop. In second lesson, clear expectations about group work was much better. I love that. I love the fact that you've seen it and you've trialed it, and you know what? We can't always get it right. We never do. Some of my best flops were assuming that children knew how to use a stopwatch and then very quickly discovering that they didn't. And I had to go right back, teach that moment, and then move on. And funny enough, the experiments worked much better when they knew actually how to use a stopwatch and I'd taught it to them. We can't always assume that children know things. Going on children's engagement topic, I think with science, we're quite lucky with children engagement on the whole. I think generally children enjoy science because it is practical. Hadn't thought of talk like a scientist, finding a way to break down scientific vocabulary, great. Even better if children could think more like scientists. Yeah. Why are we doing certain experiments? I think that's really important as well. Yep, using lots of widgets. As I said, I use a lot of widgets. Make sure they are suitable for the science vocabulary. One of the examples with widgets is I typed in spring and I got the tree spring, but actually what I was wanting was the metal coiled spring. Both scientifically accurate, but for completely different scenarios. Lots of group discussion, great. Focus on key vocabulary slightly more, incorporating scientific language, great. Even better, discussions about words. This is great, everyone. We've got loads of ideas. And it's really nice to see you reflecting on your own practices and what's going well, but also potentially taking something away. So what we're going to go through now is some ideas that you could build into your classroom. So I don't know whether any of you have come across Explorify before. It is free. It is under STEM learning. So I would 100% recommend signing up to it. A lot of people do have science weeks or STEM days, and utilising this is brilliant. Also, utilising it in early work, utilising it at the start of a lesson to get some discussion going. Now, the reason I really like the odd one out here, so it's a picture of 3. Now, Explorify have hundreds of these, and I really like them. But again, you can take the idea and tailor it to your specific lesson. So, for instance, here, the drinks menu. So, what is the same? What is different? Can you find the odd one out? Now, with this, there is no right or wrong answer. A child could say, well, it's the camels on the left because their water is frozen. It could be the beetle on the right because actually they were very lucky to find water because there's a lack of water. That might be the only water droplet in that point. It could be, but the ladybug bird is so small it doesn't need as much water. It could be that the camel carries water in its humps, which, by the way, is a misconception. Be careful with that one. So it's really nice because there is no right and wrong. Children can give their opinions really confidently without being ridiculed. Every opinion is validated. With Explorify, they also have got these, and they've got some work and background for teachers behind it as well. So really encourage you to go and find, if you have not used Explorify before, go and have a look. This is also from Explorify. And it's a what is it? I love these zoom in, zoom out. So does anyone know what it is? Have a go, type it in the chat. What do you think it is? And when we're doing it with the pupils, you can do, what do you think it is? But also you can then think about, give an explanation. Why do you think it is that? What clues are there, or what evidence is in the picture to give you a clue as to what you think it is? So we've got leather, we've got skin. Anyone else brave enough to have a go at this point? Bottom of a trainer, dog nose or paw. Love Explorify, I wish I could do use it more. Tire, all really great reasons. Now, what then happens with zoom in, zoom out is you zoom in a little bit further and you say, okay, this is the next picture. Have you changed your ideas now? Is there more clues or more evidence in the photo that maybe is changing your opinion of what it might be? So now we're talking about lizards and snake skins. Somebody else going down the route of a nose. And why do you think it's a nose? Is it because you've got the shadow there in the bottom? Is that's what giving it a clue? And I will give it away now. It is actually a dog's nose. But there's a whole load of these in Explorify. Explorify also, if you're ever doing careers and wanting to look into science people, they are building more of those types of things in, where they put a picture of a person on a background and you can ask the children, what do you think this person does? Again, generating oracy, generating talk, using scientific vocabulary, from what clues are in the picture, what evidence is there. And actually then they do the full background for you behind it. So that's another thing. So go and have a look. There's lots of different ideas there with it, Explorify. So concept cartoons. Concept cartoons I can use them at the start of an experiment to see what children think, or at the end to see after an experiment or activity to see whether they have truly grasped the understanding. Basically, what it is there are often three or four children with thoughts. So in this case, there's a picture of a skeleton in the middle. And it says, so what do you think if there was no skeleton? So I think it would, we would end up a pile on the floor. I think we could stand but not move. I don't think there would be any change. I think we could become a jellyfish. And then you ask the children, well, which do you think is right? And why do you think? Again, it's that explanation, why, those questions. Why do you think? Now, these have been created and tested in classrooms. So they were created by Brenda Keogh and Stuart Naylor. They've been thoroughly researched in classrooms around the world. And simple concept cartoon style drawings present learners with their own misconceptions and generate discussion. So it's a good way of unpicking some misconceptions that children might come up with. I created this one on my own based on the concept cartoon style. So really easy to create your own ones that fit specifically with what you're doing. Particularly Key Stage 1, they don't, the concept cartoons are mainly for Key Stage 2 or Key Stage 3. So Key Stage 1, but the idea of picking out some of their misconceptions and almost confronting the children with it as well as with correct, and then having them have those discussions to unpick why is one right and one wrong. Nice thing about concept cartoons is, again, they give the teacher notes and background to it. So in this case, I think we would end up a pile on the floor. So all of our skin and everything would end up like a pile. I don't think anyone would believe that we become a jellyfish, I hope, but you never know. So again, there is another video here. Again, I'm not going to play it. It will be, it's embedded in the PowerPoint presentation and that will be available to you. So go and have a little, find out a bit more about it and Google concept cartoons to give yourself some ideas. So some other activities that create opportunities for talk, thinking about always, sometimes, or never. A person's heart rate changes during the day. Is that always, sometimes, or never? Veins are blue and arteries are red. Is that always, sometimes, or never? And oxygenated blood flows from the heart to other parts of the body and then returns to the heart. Again, can you categorize it into always, sometimes, or never? This is a great technique for developing higher order thinking skills in the science classroom. So, you know, sometimes it's difficult to think about how can we stretch our most able children in science. This is a really good way of doing that. And again, if you have, you know, maybe you're planning 6 weeks and it's a 7-week term and you've done everything, you've managed to stay up to date, which I know can be tricky. You could always add this in. These are the types of things you could use in Science Week as well, or just a few spare minutes, maybe your activity. So sometimes I get people saying to me, oh, well, I finished my lesson, everything that we needed to do in the lesson. So I've moved on to my next lesson, which is now geography, let's say. And I'm like, but that 10 minutes could be this oracy, could be this literacy, could be this getting children's confidence in speaking, listening, communication, really giving them that chance for those oracy speaking. So utilize the time that you have allocated to your science subjects. Don't push on and go, oh, that means I can now get on with my next lesson and get ahead. No, stick with it. Utilize some of these opportunities in your classroom. So what if we didn't have a digestive system? Positive, negative, and interesting. So giving children a question and then asking them for a positive comment about it, a negative comment about it, and maybe something that's interesting that they thought of about that scenario. Chop and ordering. So really good for events that are chronological, okay, that can be sequenced. For instance, the circulatory system can be sequenced, digestive system, life cycle. This is a really great technique. It does require a lot of preparation in advance, because what you want to be doing is having the sentences, chop them up. I would put them in an envelope and pop them on a child's desk. I would also say that this is a really good technique for if you've got children that maybe are EAL or have a special educational need, that instead of them writing, particularly if the barrier is writing rather than reading, you could write the conclusions, chop them up, and then get them to reconstruct it. Takes away the barrier of writing, helps us to realize what science do they actually know, rather than can we write. So utilizing meet the expert techniques. So this would be in groups of 3, and the children alternate between being an interviewer, an expert, and an observer. The interviewer needs to prepare questions to ask the expert, maybe on the life cycle of a plant, for instance, and the purpose of each part. The expert should then use scientific vocabulary to explain their understanding, and the observer listens and ticks all the vocabulary used. So again, we're using that active listening. So the observer, you might think, oh, well, that's his job, but actually actively listening. Are they saying all the right bits in the correct manner? You know, the experts had to become the expert on the subject in the first place, but the interviewer also has to know about the subject because they have to prepare the questions. And you can get the observer to prepare what vocabulary they're expecting to hear, so they're having to think in advance, and then swap them round. Opportunities for talk for true or false. This is a great technique. And again, this is a type of thing that you can extend and change. So in the young years, Key Stage 1, it might be, you might have a tick and a cross, and you might have text chopped up, and then they can put them in true or false, tick and cross. Early Key Stage 2, you might use true or false, and for Upper Key Stage 2, you might do support or refute. So again, increasing that terminology, increasing that language. This is a great assessment tool. So how do we create opportunities for talk? We have to plan for it. It doesn't just come naturally to all of us. Some people can, after years teaching, can just come up with those opportunities. But sometimes at the beginning of your teaching journey, having a few ideas there ready to go, or a few questions just in the back of your head, is really useful. So you need to think about what the focus is of your lesson. You need to think about going back, thinking about those 3 to 4 key vocabulary you want the children to be utilising. You need to think about science capital to plan for vocabulary and talk time, and think about what questions could be asked to practice those scientific terms. I would always say link the learning that you're doing in the classroom to children's real life experiences as much as possible, both past and current experiences. So, for instance, if we looked at the EYFS statutory framework, or the national curriculum for your topic of teaching, you need to think about, find out what should the children already know from previous learning, and what will the children go on to learn in the future. You need to know that, so you need to know how far to push them, but also what to pull forward. We can think about, when should children be talking? What should they be talking about? What are we teaching in the classroom? What are the non-negotiables about? Remember, we've said all this before. What opportunities are we creating? What is that focus of the lesson? What vocabulary is key learning? So this is a recap and link that learning to children's real life. So, for example, I'm going to show some scenarios. I want you to have a think of what key vocabulary you might use in that example. How would you teach the vocabulary? What links can you make to children's lives, and what opportunities could you create for talk? So remember, we're thinking ahead. So in a UIFS, here's an example. So we might consider the question, what happens to water when it gets very cold? So we could put some water in an ice cube tray and we could put it in the freezer. Even better than that is in winter, we can make natural ice decorations. We can get the children to go and collect some sticks and berries. We can put them either in the ice cube tray, or I sometimes use one of the kitchen trays, and wait until we've got a night where it's freezing. You leave it out overnight, and in the morning, that water has turned to ice naturally. They might never have experienced that or seen that happen before. They might be used to getting ice cubes out of the freezer, but have they seen it happen because of the weather and the temperature? And then extend further, we could take that back to the summer term. This is the perfect weather for it at the moment, is what happens to an ice lolly? So we could have put some ice cubes, check for allergies and things like that. We could put some little lolly sticks in the ice cube tray with orange, some fruit juice or something like that. Let it freeze, get it out the freezer. What's happening to the lollipop now? Okay, think about, so actually observing it happen, the fact that it's melting very, very fast at the moment. Okay, so we have to eat it quickly. So making sure things like that, and they're experiencing it in their real life, is really important. So thinking about what questions could we be asking? So what happens to the water when it gets cold? What happens to the water when it gets warm again? Or what happens to the ice when it gets warm? What was it when it was a liquid? What's it feel like now? Is it still a liquid, or is it hard? Is it cold? Is it smooth? So many different questions can come out of this that they can then be answering and articulating and discussing. A Year 2 example of linked to everyday materials. Remembering children have done materials in Year 1, so they should already be confident with object, material and property. Consider the question, what material is best for a raincoat? Now, they may already in Year 1 have done what material is best for an umbrella. We're extending to what material is best for a raincoat. Thinking about waterproof. It's got to be, do you think the material should be rigid or flexible? If you think in Year 2, you might have done an experiment to do with rigidity, utilising that information from that experiment, pooling all that knowledge together into one. And the fact that actually the raincoat needs, it's a fabric. Remember, it's not a material at this point, because everything's material. We need to be more specific. Thinking about the fact that it needs to be waterproof, it needs to be flexible, not rigid. So utilising, can you see how much vocabulary we're getting in here through these discussions? Year 3 are rocks and soils. This one is the first time they've come across studying rocks and soils. However, they've probably come across soil for plants. They know what soil is, although they might call it mud. They might not use, so again, we're introducing the terminology, we're utilising more language. So consider which soil is the most permeable. Again, new word. They already know waterproof and absorbent from their materials topics in Year 1 and 2. So then utilising that information to help them understand what permeable means. So we might teach that word permeability or permeable, and we would need to explicitly teach it with a new word alert. And it's about how easily liquid passes through a material. Larger particles result more air gaps and therefore allow water to pass through. Now, if you do this experiment in Year 3, sometimes you get the result that you don't imagine, and that is because of those large air gaps. If you've put clay, and we know that soil in the ground if it's clay, can get very waterlogged and very muddy and slippery. But actually, sometimes in our experiments, the water runs through really quickly because it's broken up into larger chunks, and therefore there is larger air gaps in between it. So things like that are important to understand, and that's where your subject knowledge is really important, that you have strong subject knowledge and strong vocabulary in order to teach accurately and stop any misconceptions. Link this work with their real life, thinking about plants and the different types of soils we're going to plant them in, thinking about how much water we might need to give those plants. Do we need to give them more water or less water depending on the soil type we've got? Go and dig some soil from your school grounds and test that, not just the ones out of the packet that you buy in. You can use those as well, but use ones out of your grounds as well. Year 5, again, materials. So again, they've done year 1 and 2 materials, considering the question, are all substances soluble? So we're going to test them. So when you put sugar in tea, is it still there? Can you taste it? Can you see it? We call this dissolving, new term. A lot of children think the sugar has melted. So again, it's unpicking some misconceptions, but they do know that it still tastes sweet. So they know intrinsically that it is there. Thinking about a cake, if we put flour into water, it doesn't dissolve, otherwise we wouldn't get a nice delicious cake at the end of it. One of the things I think is really important, and actually it's becoming more and more important when you're talking to people about personal development in particular, and that's opportunities to expose pupils to language-rich environments, both opportunities inside and outside the classroom. So outside the classroom, we're thinking about our school trips. Are they related to science? What are the children going to get out of it? So Natural History Museum, Science Museum, other museums around the country. Are we growing? In the national curriculum, it specifically says we should be growing things other than just cress. So have we got some vegetables growing? A good one is radishes. They only take a couple of weeks to grow, so they will grow within your 6-week unit of work. So if that's helpful, getting children outside, the outdoor environment is language-rich environment in its own right. And then they're starting to see themselves as scientists because they're doing it. The opportunity to take language from the classroom and utilize it outside actually shows that they've really grasped hold of those vocabularies and that opportunity and that science understanding, because they can transcribe it to a different environment, which is really, really important. So some recommendations. I am coming to the end. I thought I would, because it is so hot, skipping those videos. I'd like you to go, and once you get the links and stuff, you can go and have a look at them. But I am very appreciative that some people are not in a lovely air-conditioned classroom at the moment. So recommendations. This was from one of the reports, that teachers should plan oracy opportunities in primary science lessons to enable the children to explain and develop their scientific thinking. Consider how children are applying their science ideas and relating these to real life, helping them to see that science is for them on their path to scientific literacy. And I think that's really important. The fact that all children have to take science GCSE going forward, and I know we're at the beginning of their journey, and yet it's really interesting. I'm doing a piece of research at the moment of how children love science, it seems, in primary, but actually as they get further on in their journey, they feel it's too difficult and it's not for them anymore. So really getting the children early to see themselves as scientists when they are outdoors, when they're exploring, when they are doing all these things. And it's not just about a person in a lab with a white coat. That is not science. There are so many other science careers and opportunities out there that don't come to their mind. So while I'm going through my top takeaways, this is your feedback. So if you'd like to scan your QR code, and then I'll go on to my feedback. I will come back to this slide at the end, so that if you miss it now, you have got it, and I'll leave it on for a couple of minutes at the end. But I thought, get you to start it while I'm doing my key takeaways. So, as we've said before, a reminder, a classroom filled with exploratory talk is filled with problem solving, collaboration and thinking, by Professor Neil Mercier. So, closing the vocabulary gap. Remember, home literacy environment differs from inside the classroom, which can affect the domain knowledge, the subject specific knowledge. So it's that we're talking about those vocabularies like field and field, okay? So making sure that that we're really unpicking those. So we need to explicitly teach key vocabulary. We need to plan for talk opportunities. We need to make links to children's lives. We need to put it into context. I will put the QR code back at the end when I finish my key takeaways. Expose children to and provide a language-rich environment. Think about your displays. Have you got the words up? Is there a working wall? How are we introducing that vocabulary? Are we modeling? But also, are we inviting speakers into school? A reminder that STEM ambassadors are free and will come into your school and do STEM activities or STEM talks, and making sure that, and you know, really good resource out there, STEM ambassadors, absolutely free. Utilising online resources like videos. There's been a lot of live lessons happening recently. And those live lessons, the BBC are doing a lot. There was the World Wildlife Fund, we're doing some with Steve Backshall. They did one for World Oceans Day. They are often recorded, so you might not be able to get it live because it doesn't fit in with your timetabling, but they are out there, so go back and have a look. Organise trips and utilise your school grounds in your local environment. Maybe you've got a park very nearby, utilise it. Oracy and disciplinary literacy are not add-ons, they are central to scientific sense-making. By fostering talk and literacy skills, we empower students to think, reason, and communicate ideas like scientists and collaborate effectively. Intentional questioning moves students' learning forward, and structured talk encourages deeper thinking. My big one is, if you don't have the vocabulary, you can't speak it. You can't say what you want to say. And if you can't speak it, then you can't write it. So having that oracy, having those discussions to promote that language, model those sentence structures, getting the children to model it, saying it as if they were going to write it, because if they say those full sentences, then they're able to write it down. I'm going to go back now to your feedback session. I hope it'd be really nice if people could just put in one takeaway that they are going to take away to their class and try out in September. Or even next week, you might find that you've got a spare moment. Are you going to have a go at Explorify? Are you going to unpick some language? Are you going to think about some of those some of those words that you know, oh, the children didn't quite get. So actually, I just need to go back and check that that's understood. This is the perfect opportunity to have, you know, have an opportunity to use some of those things. Speaking like a scientist, particularly as it's hot, we might have finished already our units of work. And if we have, don't give up your science lesson. Make the opportunity to create a discussion-rich environment for a lesson based around science and STEM. Thank you very much for coming. I hope you have a lovely rest of term and a really fantastic summer holiday when it arrives. Thank you very much, everybody.